everyone. So today we will be covering section 1.6, which is more equations and applications. If you look at my notes over here, as you can see, we're going to kind of jump around in this section, and we're going to do section 1.6.5 first, which is solving equations in the quadratic form. So with section 1.4, it was all about solving quadratic equations. Alright, so now what this section is doing is it's just kind of taking it into a step further, where it kind of looks like a quadratic equation, but we'll have to use some substitution first before it looks like one, right, that we recognize. So let's dive in to an example. So the example 1 here, right, we are given 2x squared minus 3 quantity squared plus 36 times the quantity 2x squared minus 3 plus 35 equal to 0. Right. So how do we know this looks like a quadratic equation? Well, there's something squared, and then a coefficient with times that something, and then a constant. Right. So the biggest thing here is that we know it's a quadratic because there's a squared right there. Right. So what are we going to do first? The first thing we're going to do is we're going to substitute. So when we substitute, make sure you don't use the same variable, right? Because then things can just, towards the end, things will get really confusing. So I'm going to use a different variable. I'm going to use y, right? And I'm going to let y equal to 2x squared minus 3, righty? The reason why I did that, so if I substitute that, wherever I see a 2x squared minus 3, I'm going to replace it with a y. And when I do that, I get y squared plus 36y plus 35 equal to 0. Right? If I substituted the y back in, I would be left with 2x squared minus 3 quantity squared, and then all that stuff. Right, now this looks more familiar for us. This looks like a quadratic equation. So what are we going to do? We're just going to solve like normal. Righty? So over here we want to find two numbers, right, that multiply to be, I'll make that x bigger. So we want to find two numbers that multiply to be AC. So we want to find something at 1 times 35, which equals 35. Right, and we want to add it to be 36. Right, so I can let you guys do this t-table. Okay, but what you'll get is you'll find that it's going to be 1 and 35. Right? Because my a is 1, I can just put these numbers in. So this is y plus 1, y plus 35 is equal to 0. Right? Use the zero product property. Okay? So I get y plus 1 is equal to 0, or y plus 35 is equal to 0. Okay, then I get y is equal to negative 1, or y is equal to negative 35. Okay, most of the time we would be done right here. However, what is our original variable? Our original variable is x. We solved for y, so we're not done. So what are we going to do now? How are we going to solve for x? Now that we've solved for y, what we're going to do is we're going to substitute y back in. So y, we said, was 2x squared minus 3 equal to negative 1, or we have 2x squared minus 3 is equal to negative 35. Right. So now let's solve. So focusing on this first equation, right, I'm going to add 3 to both sides, so I get 2x squared is equal to 2. Right. Divide both sides by 2, I get x squared is equal to 1. And then when I use the square root property, I get x is equal to plus or minus the square root of 1. But what is the square root of 1? It is 1. So I get x is equal to plus or minus 1. Alright. Again, like I mentioned in class, if you want it, you could work with these equations at the same time. I do know that it does confuse people when I do it. When I work on both, right? So that's why I'm focusing on one at a time, but you can do both if you'd like. Right? So I'm going to add 3 to both sides. When I do that, I'm left with 2x squared is equal to negative 32. Right? Because when I add 3 to both sides, I'm left with negative 35 plus 3. Right? They both have opposite signs, so we're going to subtract, and we keep the sign that's bigger, which is the negative. Right? I'm going to divide both sides by 2, right? And when I do that, I'm left with negative 16. Right? And when I use the square root property, I'm left with x is equal to plus or minus the square root of negative 16. Okay? What is that? That is x is equal plus or minus 4i. Okay? A step I skipped. Okay? This is optional. Doesn't matter. Okay? I pulled out the I first. Right? And then 4 squared is 16, so the square root of 16 is 4. Okay? So since we got that, so now that we solve for x, we can write it more like if it says just put commas, I can do plus or minus 1, plus or minus 4i. Okay, you can also put plus 1, minus 1, and then 4i, negative 4i, doesn't matter. Okay, and then, or you can write the solution set. Alrighty. Okay, and this is how you solve a quadratic equation using substitution. Okay, or where you have to substitute something before you solve. Right? Let's do another one. Okay. This other one, okay, we are given 2w to the 2/3 is equal to 3w to the 1/3 plus 20. Right? So first of all, okay, what I want to do is I want to set one side equal to 0. So I'm going to subtract the 3w to a third plus 20. I'm going to subtract both of them over. The reason why is because I know w to the 2/3, this is bigger than w and a third. Alright, if you're unsure, you can just get a concrete number. If you let w equal to 2, if you say 2 to the 2/3, alright, this is saying this is the squared and this is the root. Okay, so this is also equal to the cube root of 2 squared. This is the cube root of 4. Okay, on the other hand, if I did 2 to the 1/3, that is just the cube root of 2, right? This is definitely bigger than this one, right? So, and like I said, I always want the leading coefficient to be positive. So let's rewrite this. Okay, so this one's a little more tricky. I know the first one's kind of more obvious on what you would use for your substitution because you just kind of pick the one that looks the same. Okay, but this one I have w to the 2/3 and I have w to the third. So what am I going to substitute here? Okay, so before I do that, I do want to recall, so remember we have that x to the a to the b is equal to x to the ab, right? And what happens when I multiply fractions, so if I did like 2 times 1/3, this is 2/3, right? Okay, so what I'm going to do is I'm actually going to look at this middle term here. So kind of a good rule of thumb is for this middle term, that's usually what you want to substitute. Okay, usually. Okay, so I'm just going to let x equal to w to the 1/3. Okay, I guess I'm kind of getting ahead of myself. So how do I know this can be a quadratic equation? The biggest thing here is that in the numerator, this is a 2. Okay, so I know in some way I can substitute something to where this can be something squared. Right? And then when I do that, okay, I'm left with 2x squared minus 3x minus 20 is equal to 0. And how do I know this is the same? Because if I substitute that w to the 1/3 back squared, remember, so this is going to be w to the 1/3 times 2, which is w to the 2/3. Right, so that's the same, and then this one, I'm just replacing it. Right, so this was substituted correctly. So now that this looks like a quadratic equation, we can go ahead and solve for it. Right? So now what I'm going to do is I'm going to find two numbers that multiply to be, so 2 times negative 20. We want to find two numbers that multiply to be negative 40 and add to be a negative 3. Okay, so if I do, so I want to do negative 40, right? So since it's negative, I know I want to deal with positive and negative numbers. So of course you can go down, but let's see. If I do 4 negative 10, that won't work because I'm left with the negative 6. Not 2 and 20. 4. How about, oh, geez, 5 and 8, right? And I want to make 8 my negative, right? Because since this is negative, I want my bigger number to be negative. When I multiply those, I get negative 40, and when I add them, I do get negative 3. So this is it. So this is going to be 5 and negative 8. Okay. So now we're just, because our A is 2, I can't do that fancy trick. So what I'm going to do is I'm just going to rewrite this negative 3. I'm going to say this is going to be plus 5x minus 8x minus 20. Alrighty, and then if I combine these, I get negative 3x, so I didn't change the equation. Now we're going to factor by grouping. Right, I'm just going to rewrite it. Okay, so keep in mind, remember this is not the same. Okay, can't do that because then if you distribute the negative, you get something completely different. So make sure you put the parentheses around that negative sign as well. Okay, now I'm gonna look for the greatest common factor. In that case, it's just x, and I'm left with 2x plus 5. Right, and over here, I want this to be positive, so I know I'm gonna factor out a negative. Right, and then my GCF here is so 4. When I factor out a negative 4, I'm left with 2x plus 5. Right? So these two, they both have a 2x plus 5 in common, so I'm going to factor that out. And when I factor out the 2x plus 5, I'm left with x minus 4. Right? Zero product property, so this is 5 is equal to 0, or x minus 4 is equal to 0. Okay? So this is going to be 2x is equal to negative 5, and this is x is equal to negative 5 over 2. Or, okay, when I solve this is x is equal to 4. So, to make it more neat, and call it that. Right, or you can do the solution set, which is negative 5 over 2 fourths. Oh, shoots. See, guys? Jumped ahead of myself. Okay, this is not our final answer. Why is it not our final answer? We just solved for x, but what is our variable we're working with? We are working with w. Right, so don't do what I do. Okay, don't rush. Right, so we solved for x, but our variable is w, so what are we going to do? We're going to substitute w back in. So again, we made x to be w to the 1/3, right? This is equal to negative 5 over 2, and then w to the 1/3 is equal to 4, right? So keep in mind when we solve for a variable, we want the coefficient to be 1 and the degree to be 1. So both of them, the coefficient's already 1. We just need the degree to be 1. So our question over here, I'm going to bring it to the side. So I'm going to say w to the 1/3. What do I have to do times a would make it w to the first? Okay. So one thing, I don't remember what this is called, but essentially, so if I do that, this is going to be w and then a over 3. Okay. So the thing with the rule here is if you have a common base, right, you can set the exponents equal to each other, right? I think that's called the power property, maybe. I do not remember. Right, so then a is equal to 3. So what does that tell me? This tells me I am going to cube each side. Right? If you already knew that, great, but I just want to show you guys, yeah, just how, if you are unsure, this is a way to find it. Right, so when I do w cubed to, or w to the 1/3 to the cube, right, that gives me w to the 3/3, which is w to the first power. Right, negative 5/2 cubed, right, when I do that, this becomes negative 5 cubed over 2 cubed. Right, you have to do both the numerator and the denominator. Negative 5 cubed is negative 125, and 2 cubed is 8. Okay, over here, again, so it's the same exact thing, so I'm just going to cube it. Okay, and when I do that, I'm left with w is equal to, and then 4 cubed, 64, right? Because 16 and 4, yep. All right, so now we solve for w. So our solution is w is equal to negative 125/8, 64. All right. So that is it for 1.6.5. So now we are going to go back and we're going to look at section 1.6.2. Alright, and then we, which is all about solving rational equations. Okay, so let's look at example 1. Okay, example 1, we're going to solve for the variable, and we are given the equation 3 over y squared minus y minus 2 minus 4 is equal to 1 over y minus 2. Okay? So note the key to solving rational equations is to multiply both sides of the equation by the LCD of all the terms so we can get rid of the fractions. Right? So, but that's just to get rid of the fractions. But first of all, what do we do when we are dealing with rational equations? Always. We're always going to find the restricted values. Okay, so we're going to gather all the denominators that have variables. So I have y squared minus y minus 2. We want to set that equal to 0. And we also have y minus 2 equal to 0. I'm going to solve the easier one first. Okay, so we know y cannot equal 2. And then over here we'll have to factor. Okay, this factors into y minus 2, y plus 1. Right, and I solve for that. We get y minus 2 is equal to 0, or y plus 1 is equal to 0. Okay, when I do that, I get y is equal to 2, or y is equal to negative 1. Okay, so what does that mean? That means y cannot equal, okay, negative 1 and 2. And you just have to put the 2 once, right? You don't got to put it twice. So this is our restricted values. Now that we have the restricted values, what we are now going to look for the LCD. Right? So before we find the LCD, I guess we can rewrite our equation. So it's going to be 3. We already factored the y squared minus y minus 2. That is y minus 2, y plus 1 is 4. Okay, some of you may be wondering, if you want, you can factor out this denominator first, and then you can find the restricted values. It doesn't matter. Right? But we have this, alright, so we are looking at the y minus 2 times the quantity y plus 1, and then y minus 2. So what is the LCD? The LCD is just y minus 2, y plus 1. Right? We're going to take each unique term, so if I had so if I had the y minus 2, y plus 1, okay, and then the y minus 2, what you do is you list out all the unique terms. So I have y minus 2, y plus 1. All right, you just list it once, and then you have to look which one has the highest exponent. Over here, this is to the first and to the first. So this is to the first, and then you can imagine this is here, but this is a 0 because anything to the 0 power is 1. So the highest power with the y plus 1 is just 1. Right, and so that's why the LCD is the quantity y minus 2 times the quantity y plus 1. So what am I going to do with this LCD? I'm going to, multiply both sides. Okay, like I said before, if you want to just bracket the whole equation and put that, that's fine. Just make sure you distribute every single term. Right, that's usually why we just do it this way. Right, but I'm a little lazy, don't want to write that all. Okay, when I do that, so I'm just going to write this out so we can easily see what we can cancel. Okay, but if you're comfortable with this, you don't have to. Okay, 1 times this is just that, so just put that on top, and then y minus 2. Alrighty, so when I look at this, these y minus 2's, they can cancel, and these ones can cancel. Alright, and then over on the right, the y minus 2's can cancel. And when I do that, I'm left with 3 minus 4, and then y minus 2, y plus 1. These didn't cancel. And this one, I'm left with y plus 1. Alrighty. So again, what is our goal? Our goal is to solve for y. Okay, so I see there's a couple y's on both sides. Right, and then for these, they're a little trap, so we have to FOIL it out. Okay, so luckily we don't really have to do that much work, right? Because we already know it. This is just y squared minus y minus 2. Okay, I can do that because I mentally checked it before. Right, if you didn't mentally check it, I'd still FOIL it. That's a great opportunity to check your work. Okay, and we're going to distribute this negative 4, and when I do that, I get negative 4y squared plus 4y plus 8 is equal to y plus 1. Righty? Let me combine like terms, so negative 4y squared plus 4y, and then 3 plus 8, that's 11. Okay. I'm going to move all these terms on our left over to the right. The reason why is because my leading coefficient is negative and I want it to be positive. Okay, so when I add, I'm going to add 4y squared to both sides, so I'm left with positive 4y squared. I'm going to subtract 4y from both sides, and when that happens, I get negative 3y. And then I'm going to subtract 11 from both sides, and then I'll get negative 10. Okay. So now, we factor. Okay, so making a big X, I'm going to ask what two numbers multiply to be 4 and then negative 10, so negative 40, and add to be negative 3. Okay, so let's make a table. Negative 40. Oh, this is deja vu. Okay, this is going to be, what did we determine? It was negative 8 and 5. Right? They add to be negative 3, so this is good. So let's rewrite it. I want my 0 to be on the right, so I'm just going to write the right side first. So this is going to be 4y squared, okay, and then minus 8y plus 5y minus 10 is equal to 0. When I combine these like terms, I still get negative 3y, so this is good. Now we're going to factor by grouping. Okay, I can safely put these over here because this 5y is attached to a positive, so I can just put the parentheses on the 5y. Okay, because if I distribute it, I would still get the same answer. Now, let's look at this, and what is the greatest common factor? It is going to be 4y, and when I factor that out, I'm left with y minus 2. Okay, in the second term, the common one is 5, and this should be y minus 2. Okay. If you're not really as familiar with factor by grouping, one thing is when you do factor by grouping, this end, there should always be a common binomial in there. Right, in this case, our common binomial is y minus 2, so let's factor that out, and we're left with 4y plus 5 equal to 0. Okay, so I have y minus 2 is equal to 0, or 4y plus 5 is equal to 0. So we get y is equal to 2, or we have 4y is equal to negative 5, so then y is equal to negative 5 over 4. Right? Before we say we're good, okay, remember we have to keep in mind what are our restricted values. Our y cannot be negative 1 and 2. And what do we have right here? Right here, we have a y is equal to 2. So this is not a solution. This would make our denominator 0. So what is our solution? Our solution, see, when I made my notes, I did not check that. Okay, so this is not a solution. Okay, negative 5 over 4. Right? Or you can do the solution set negative 5 over 4. Right? Now, last example for the day. Okay, let's solve. So example 2, let's solve 2x over x minus 4 minus 3x plus 2 is equal to x squared plus 14 all over x squared minus 2x minus 8. Right? So before I find the restricted values, I'm actually going to go in a different order this time. I am going to factor our denominators first. Okay? The first two terms, I can't factor the denominator, so they're just going to stay as is. Right? But when I look at the x squared minus 2x minus 8, this becomes x minus 4, x plus 2. Right? Which is very convenient for us because when we find the restricted values, we have x minus 4 is equal to 0, x plus 2 is equal to 0, and then we have this x minus 4 times a quantity x plus 2 is equal to 0. But when we use the zero product property, we're just going to be left with the first two. So let's just do that. Okay, this same values. Okay, so what does that tell us? That tells us x cannot be negative 2 and 4. Okay, and so I see a mistake right here. Okay, and that was my own fault for just kind of rushing through the problem. Right, so now that we found the restricted values, we want to find the LCD. So the LCD, we're looking at all these denominators again. Okay, so the LCD, so I'm looking at each individual term, like the unique term, which is x minus 4 and x plus 2. Right, and then the highest exponents of everything is just 1. Right, so that's our LCD. So what are we going to do? We're going to take this whole thing, and we're going to multiply it by x minus 4, x plus 2. Right? We're just going to multiply it to all three terms. Right? Again, I'm going to write everything out so we can easily see what needs to be canceled. Okay, keep in mind when we multiplied this, this has to be in parentheses, right, because it's a group. Alrighty, so now looking at this first term, we have x minus 4s that can cancel. So then I'm left with 2x times x plus 2. Right, over here the x plus 2's cancel, so I'm left with the negative 3x minus 4. And over here, x minus 4's cancel and x plus 2's cancel. So I'm left with the x squared plus 14. Right? Now that we've gotten rid of all our fractions, now we just need to simplify things, move things around so we can solve for the variable. So remember, we want to solve for x, but there's x's everywhere. So let's free some of them before we rearrange. So over here, the 2x, I'm going to distribute. So I'm left with 2x squared plus 4x. Okay. Over here, I'm going to distribute this negative 3. Okay, so this is negative 3x plus 12. And this is x squared plus 14. Okay, again, let's look at our leading coefficients. I have a 2 and a 1, so I'm going to move this x squared plus 14 over. Okay, actually, before I do that, let me simplify. Okay, I combined the 4x and the 3x, and it became just 1x. Alright, so if I subtract x from both sides, I'm left with x squared. There's no x, I'm going to move over, so that stays the same. And if I subtract 14 from both sides, I'm left with negative 2. Okay. And so when we factor this, so again, what are two numbers that multiply to be negative 2 and add to be positive 1? When you do everything, you're going to get positive 2 and negative 1. Okay, so this is, and then because the a is 1, then we can just put the plus 2, x minus 1. So this is x plus 2 is equal to 0, or x minus 1 is equal to 0. So we get x is equal to negative 2, or x is equal to positive 1. Right? So, again, before we say it's done, we have to look back to what our restricted values are. We cannot let x equal negative 2 and 4 because those would make our equations undefined. Right? So what does that mean? This means that this negative 2 is not a solution. So that just tells us x is equal to 1. Okay. One thing I want to note is not all rational equations, it's not going to happen every time where you just end up with one solution. There's still times where you could still have both solutions. And there's actually also times where you have no solution because both of them are restricted values. Alright, but that's it for today. So yeah, and then we'll do these class problems on Friday.